Hello chemistry fans, and welcome back to chemistry problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. What is the product of the following reaction? Alright, so we have ourselves a triacylglycerol, a saturated triacylglycerol, so it's probably a solid, so it's probably animal fat. And we're going to add acid or an enzyme. Enzymes we'll learn more about in chapter 16. They are biological catalysts, so they'll basically catalyze a reaction, make a reaction go faster, if you will. Okay, so, this is a hydrolysis. Hydrolysis. So we have acid, and there's also going to be water in this reaction. Whenever you see acid in Chem 32, you can always assume there's water there too. In other classes, you can't always assume the water, but in Chemistry Chem 32, feel free just to assume that there's water in this reaction. So now, notice we have 3 ester groups. And when you react any ester, it doesn't have to be a triacylglycerol, any ester, when it reacts with acid and water, will give you an alcohol and a carboxylic acid. Okay, so esters will react to give you alcohol and a carboxylic acid. Remember all those classes of compounds I told you should learn? This is why. So we're going to have an ester reacting to give an alcohol and a carboxylic acid. And it's going to break the ester bond. So the ester bond is going to break. The ester bond is the bond that's going to get destroyed in this reaction. So the products will be, and all 3 ester bonds are going to go, not just one of them. All 3 are going to be hydrolyzed. So what the product will be, let me get my black marker here. You'll get this. Okay, these are alcohols, right? There are 3 of them attached to the same molecule, that's okay, but there are alcohols. If we just ignore the bottom, that's an alcohol. That's an alcohol. And that's an alcohol. So we have 3 alcohols. So just like I said, the ester is going to break to give us alcohol plus carboxylic acid. And I like exclamation points because that's pretty exciting. The ester is going to break to give us an alcohol plus the carboxylic acid. So here's my alcohols. Okay, I broke this bond. That's fine. I broke this bond. And here's my alcohol. So here, this oxygen here, let's put little dots by it. Those are right there. Okay? And I'll use blue this time to differentiate. I'll get a carboxylic acid. One, two, three, four, five, six, 7, 8, 9. One more, and make sure you count your carbons. Don't mess that part up. There. And these are acids. So over here, I have my alcohol. There are 3 of them. And let's put little red dots here. That's where those came from. Okay, and over here, of course, are my carboxylic acids. Let's use the red one again. So an ester will break to give you an alcohol plus carboxylic acids. So here I have 3 esters. They break to give me 3 alcohols, because I had 3 esters. I'm going to have 3 alcohols. 1, 2, 3, and 3 carboxylic acids. I had 3 esters, so I have 3 alcohols and 3 carboxylic acids. It will always work that way. Okay? The ester will always break or do a hydrolysis to give me alcohol plus carboxylic acid. Okay? It looks confusing because there's a lot going on. That's why I'm breaking it down to ester breaks to give me alcohol and carboxylic acid. And that's called a hydrolysis. Hydrolysis means water cuts or breaks. Ester. Hydrolysis means break into an alcohol and a carboxylic acid. Every time. Okay? Now I know it's a lot, and I know it's probably quite a bit to take in at one time, so maybe you want to watch the video twice, or maybe you just want to raise your hand, call a tutor, and see if the tutor can give you a little bit of help on this, or come on by my office hours. Either way, don't sit back on this and don't let it get away from you. It's an important concept. All right? Now with that, I wish you good luck and good chemistry.